When dividing monomials, we are actually just going to subtract our exponents when we have the same base. So for our first example, we have c to the 11th divided by c to the 8th. So I'm going to subtract my exponents. So 11 minus 8 is 3. So I get c to the 3rd power. For our next example, I get g to the 3rd minus g to the 1st. So I'm going to get g squared over or times h to the 3rd because 5 minus 2 is 3. Go ahead and pause the video and try these on your own. So for my first example here, I'm going to get x to the 1st power, so it's just x, times y to the 3rd. And then I get, for my second one, k squared, m to the 7th, and I get p to the 0 power. And anything to the 0 power actually just equals 1, and we'll write that definition down a little bit later. So this really becomes k squared times m to the 7th. When I have a power of a quotient, like x divided by y in parentheses times m, I'm actually just going to get x to the m over y to the m. And if you take a look at this example, you see that my 5 just distributed to each one. So for our first example here, we would get 3 to the 4th over 5 to the 4th. And then we can simplify that and actually solve it all the way out. So 3 to the 4th power is 81, and 5 to the 4th power is 625. And this actually can't be simplified anymore, so my answer is solved. So let's take a look at this example. We have 3p to the 3rd power over 7, and that's all taken up to the power of 2. So the first thing I'm going to do is I know that my exponent outside can go to both of my terms. So I'm going to have 3p to the 3rd squared over 7 squared. And then, as from my previous lesson, I know that I have a power of a product. So this is actually going to be 3 squared times 3p to the 3rd squared over 7 squared. And then when I simplify this, I'm going to get 3 squared is 9. And p to the 3rd times to the raised to the 2nd power is actually p to the 6th because I multiply my exponents. And then 7 squared is 49. And so I'm finished right there. Go ahead and pause the video and try this one on your own. So the first thing that I'm going to do is I'm going to have 5x to the 5th times y squared over 6 squared, which is going to equal 5 squared x to the 10th y to the 2nd over 36. So I'm going to get 25 x to the 10th y squared over 36. 25 over 36 cannot be simplified anymore, so that is my final answer. Go ahead and pause the video and try this one on your own. So the first thing I'm going to have is 4 cubed x to the 9th over 5 cubed y to the 12th. 4 cubed is going to be 64 x to the 9th over 125 y to the 12th. And 64 over 125 will actually simplify to 13x to the 9th over 25y to the 12th power. The zero exponent property says that any non-zero number raised to the zero power is equal to 1. So 15 raised to the zero power, no matter what, equals 1. The fraction b over c raised to the zero power equals 1. So no matter what, anything that's taken to the zero power is going to equal 1. The negative exponent property is I'm going to, whenever I have a base taken to a negative exponent, I want to use the reciprocal, and then I still have that same exponent that's on the bottom. So if I had, we'll take a look at our first example. If it's 2 to the negative fourth, I'm going to have 1 over 2 to the fourth, and then 2 to the fourth becomes 16. So my answer is 1/16. On the reverse side of that, if I have 1 over a to the negative power, I'm just going to take the reciprocal of that and make my exponent positive. So if I have 1 over j to the negative fourth, I take that reciprocal and I make the exponent positive. So I'm going to get j to the fourth power.